In this proof, I know that AB is a perpendicular bisector of XY. I'm supposed to prove triangle XAB is congruent to triangle YAB, but I don't have a drawing. So that's where I need to start. I'm going to start by drawing AB, a perpendicular bisector to XY. Perpendicular means 90 degrees. Bisector means chops right in half. Now, my drawing might not be perfect, but this is a 90-degree angle, or it's supposed to be, so I'm going to mark it that way. Perpendicular. Here's A, here's B. And bisector of XY, bisect means chops it into two equal pieces. This equals this. So AB is a perpendicular bisector of XY. Even if my drawing doesn't look perfect, believe the way it's marked. I want to prove that triangle XAB, I'm just going to draw it in here, is congruent to triangle YAB. When I see a right angle, my mind thinks hypotenuse leg, but hypotenuse, XA, I don't have a way to get that. I do, however, know that side AB is congruent to itself. So when I write my proof, statement, reason, I think I'm going to be able to prove those triangles are congruent by side, angle, side. First, I'll start with the given. AB is a perpendicular, that's a symbol for perpendicular, bisector of XY. That's given. Knowing that, I know that angle ABX is congruent to angle ABY, and I know they're equal to 90 degrees. That's the definition of perpendicular. I know that XB is congruent to YB. That's the definition of bisector. And that last part right there, AB, is equal to itself, congruent to, by the reflexive property. I have enough information to prove those triangles are congruent. Side, angle, side. Triangle XAB is congruent to triangle YAB by side, angle, side.